For this example, we're given a function and we're asked to graph that function and its inverse on the same xy coordinate system and then state the domain and the range of each function. So we'll start with f of x equals x squared minus 1. I'll graph this one in blue. We know that this is the graph of a parabola since we have the x squared, and we'll come up with a few points. So I could have written x, f of x, or simply x, y. These will be the points. Let's let x equal 0 because we're given this restriction that x has to be greater than or equal to 0. So if x is 0, if we substitute in 0, we get 0 squared minus 1, which is negative 1. If we let x equal 1, we'll get 1 squared minus 1, which is 0. And let's do one more point. Let's let x equal 2. We'll have 2 squared, which is 4, minus 1, which gives us 3. Now, the reason that we have this restriction that x has to be greater than or equal to 0, you'll see when I graph it. Notice when I graph 0, negative 1, 1, 0, and then 2, 3. Now, this is just the graph of half of a parabola that is just shifted vertically down 1 unit from the origin on the y-axis. The reason that I have this restriction that x has to be greater than or equal to 0, because if I had the other half of the parabola drawn in here, then the function would not be 1-to-1 because it wouldn't be able to pass the horizontal line test and then it wouldn't have an inverse. But if I have a restriction that x has to be greater than or equal to 0, this function now not only passes the vertical line test, but also the horizontal line test, and this function will have an inverse. So now we're going to graph the inverse. And I'll do the inverse function, f inverse of x, in red. So in order to plot some points, I'll simply just switch the domain and the range of the original function. In other words, I'll switch the x and the y value to come up with the points for the inverse function. So instead of 0, negative 1, now I'll have negative 1, 0. Instead of 1, 0 up here in blue, I'll have 0, 1 down here in red. And finally, instead of 2, 3, I'll have the point 3, 2. So let me plot these points in red. I have negative 1, 0. I also have 0, 1. And I have the point 3, 2. And let's connect those with a smooth curve. And what I've just graphed in red is f inverse of x. So let me label red as f inverse of x, and I'll label the blue as f of x. So now we've graphed both of these on the same xy coordinate system. Next, we want to talk about the domain and the range of each. So let's start in blue, the domain of our original function f of x. Well, actually, we were given the domain. X had to be greater than or equal to 0, and I normally write the domain in interval notation, so I'll write it including 0 as a closed interval to positive infinity. Let's look at the graph and see if that makes sense. For this blue curve, the lowest value that I ever see for x is right here on the y-axis. This point right here, 0, negative 1. The x value is 0, and I don't go any further to the left. So the x values do go from 0 to positive infinity. In the range, remember the range means what y values do we have on this graph? Well, let's look at this graph in blue. Notice that the lowest y value I ever see occurs right here at this point, at the point 0, comma, negative 1. Therefore, the y values are such that y is greater than or equal to the value negative 1. And in interval notation, that will simply look like negative 1 to positive infinity. Now we're going to look at the domain and range of the inverse function. So the domain of the inverse function is the same as the range of the original function. But remember, domain, we're talking about x. So The domain of my inverse function is the same as the range of the original function. So I need x values that are greater than or equal to -1. Let's see if this makes sense on my graph. In red, my x values look like they go as low as -1, and then they're always to the right of -1. So x is greater than or equal to -1 makes sense. In interval notation, that's just -1 to infinity. And finally, the range of this inverse function. Remember, the range of the inverse function, I'm talking about the y values now, the range of the inverse function is exactly the same as the domain of the original function. So I need y values that are greater than or equal to 0. So I can write that in interval notation as 0, infinity. Let's look one more time at our graph. Notice that this graph in red is what I'm talking about. The y values do go as low as a value right here of -1, 0. So the lowest y value I see has a value of 0, and then the y values are greater than that. So from 0 to infinity is the range of that inverse function.